So in this session, I'm going to be talking about adaptive teaching and then looking at some practical uses of it in science lessons. So what exactly is adaptive teaching? Well, it's all about creating an inclusive classroom, understanding students' needs and providing an opportunity for all students to experience success. So it is referenced in the early careers framework, section 5. So it states that it's about providing opportunities for all students to experience success by adapting lessons whilst maintaining the highest expectations for all, so that all pupils have the opportunity to meet expectations. It's also in the teacher standards, standard number 5, adapt teaching to respond to the strengths and needs for all pupils. So adaptive teaching replaces differentiation. This table highlights some of the differences. So like I've already said, it is about being ambitious for all. It's about teaching to the top. It's about planning one lesson, making it accessible for all, not lots of little mini lessons for different groups, or creating lots of worksheets for different students, or changing the curriculum outcome for certain types of students. It's about judging in the moment and then responding to it. And research does show us that what's good for the SEN, the pupil premium, the low priority attainer students in the class who are struggling to access learning is good for all students. But to do this successfully, you do need to know your students and you need to have a range of formative assessment methods that you can use. So it was mentioned in the Programme for International Student Assessment 2015 that adaptive instruction is one of the approaches most positively correlated with student performance. So how does it work? For your lesson, you need to know your students. Who are your EAL students? Who are your SEND students? Do you need resources printed in a particular size font on a particular coloured paper? Do you need to consider a reader pen, proximity to the board, printing off a list of translated words for them? Then know your curriculum. What prior knowledge do they have? What are you expecting them to know? Is that going to differ between different students from different primary schools? Is that going to differ between students depending upon the set they were in last year? Have they had long-term supply? Have they had a non-specialist teacher? Then anticipate any of the barriers for learning they're going to be. So is it some new subject-specific vocabulary? Is it common misconceptions that go along with this topic that we know from teacher experience? And we'll consider some of these specific examples in a moment. Then during the lesson, formative assessment is going to be key. So it's those diagnostic questions, those hinged questions that you plan for in advance. Determine you've taught a specific chunk of the lesson. Have students got it? Are they ready to move on to the next bit? Are they ready for their deliberate practice? So mini whiteboards, a great way to do this. You can assess the understanding of a large number of students really quickly. Low stakes testing, thumbs up, thumbs down, quizzes, keep it varied, keep it fun, keep it engaging. And we'll look at a few more practical examples of this at the moment. Then after the lesson, we've got to consider where are they at? What additional support or challenges are needed? Who achieved the outcomes? Who exceeded it? What are you going to do next? So now let's look at some specific examples. So one of the things before the lesson we said it was important to determine students' prior knowledge, to know your curriculum. So perhaps it's a quick do now quiz at the start using the mini whiteboards. From their answers to this, you're going to determine what they already know. How much do you need to chunk it? Do you need to go back and reintroduce some bits? What analogies are going to be useful for you? How can you manage their cognitive load in this lesson? And there is the opportunity to be using AI in this, using some of the digital technologies that exist. So, for example, Sensory Learning, set the diagnostic quiz, get the results, determine, okay, so which question are most students getting incorrect? I can see from this diagnostic, they struggled with question number 3. Well, I need to address that before I can expect them to move on to the next part of this lesson, or I need to address that in a slightly different way to what I did last lesson if they're going to access this and get to the next point. Tasmai will do similar. It will colour code it for you. Identify where are the struggles, where are the misconceptions, what am I going to do, how am I going to respond to this? And it's possible to use Microsoft Teams, Google Classrooms, write your own quick recall quizzes, set them to students, get the results in, they're all marked It will mark it for you, and then you know, where am I pitching this lesson? What do I need to do? How am I responding to the students to make sure every single one of them can access my ambitious curriculum? So again, another step before the lesson, you know what tier 2, tier 3 terminology you're going to use, but explicitly teach it. Remove that barrier for students. Tell them, what are those words? What is its definition? Then expect students to use the FRAIR model, and there's lots of different versions of it. They can include it pictures, similar words, opposite words, put the word in a sentence, examples, non-examples. So check they fully understand this word that you have taught them before you try and then teach them the science that goes alongside with it. Respond to them. If they aren't able to complete the FRAIR model, let's consider what else. How can I change it? How can I get this meaning of this word across in a different way? So got here again, a diagram, label it. What can you use filtration for? What can't you use filtration for? So explicitly teach that language. Now, as said during the actual lesson, formative assessment is key. Determining what they have understood so far, what are the misconceptions, respond to that, adapt your lesson, ensure every student is coming along with you. So whiteboard's a great way of doing this. Set the question, allow a bit of thinking time, have your signal, students show you the response. Very quickly, you can assess all students, where are they within your lesson? Are they accessing it? What changes do you need to respond to in that moment? And it doesn't just have to be questionings on many whiteboards. You can do verbal questioning to individual students, so cold calling on them. Direct your questions, plan the questions ahead. Who are your high priority attainers? Who are your EAL, your SEND? Who are the students you're anticipating from your knowledge of them that are going to struggle? So ask different tiered questions to them. If students don't know, that's okay. Pass it on to someone else. Repeat that question to them later on in the questioning session. Student gets it wrong, pass it on to another student. Come back to them. Get it half right. Probe them, push them, use some tier 2, tier 3 words. Bounce it to someone else. Can they use the correct tier 2, tier 3 words? Bring it back to the other students. Student gets it right, extend them. Ask them that higher order linking question. Where is that knowledge at? If actually they've got this assessed, well, where's your challenge going to come to them? Ask students to evidence it. How? Why? Bounce things along. Who gave you the best answer? Why was that the best answer? So you can really gain an understanding of what students know, and you can then adapt to your lesson. Have they actually fully understand it, and you need to add some more challenge in? Have they not understood it? You need to go back, take it back a step, readdress the misconception, use a different analogy. So scaffolding is key to this idea of adaptive teaching. So one of the methods that is used is that you can use for calculations is this FIFA method. It's from a blog, E equals MC squared and all that. So it's a really good physics blog. Lots of worked examples, lots of analogies, lots of models. Great if you teach physics, goes all the way up to A level, but also non-specialist teaching physics. Great for us as well. So scaffolding is key. One of the ones that we use is the FIFA method. So it's important to remove the scaffold as students no longer need it. And that's going to depend upon different students at different times. And it's up to you to know your students and to respond to that. So a calculation, for example, I would do the I do example. So here's the question. I'd read it aloud to student, tell them what do I know within this? Well, I can see the velocity in here. I am being told the mass in here. Right, I will write FIFA down the side. That's my nomic. That's how I'm going to remember what to do. So then I'm going to write my formula down. Then I'm going to insert my values into it. Now I'm going to fine tune it. I need to do 20 squared. Right, I'm going to write my answer. I need to remember to include units. So I'm going to verbally think aloud for students, show them how to use that mnemonic, show them how that scaffold is helping them to achieve. Then the we do example. Well, perhaps we do, you're still going to put FIFA down the side to them as a reminder. Then help them and get them to show you that they are with you at this point in the lesson. Target the question at particular students, or get them all to do it on the mini whiteboards, be holding it up to you. Depends upon where you feel those students are. Did you anticipate they were going to struggle with this? Did you anticipate they were not? That's going to assess how you're going to do this we do. Then when it comes to the you do, well, at this point, scaffolds are obviously only ever meant to be a temporary thing. So you've got to make the judgment call here for your class. Do they need FIFA on a piece of paper in front of them for every single question? Or have they been using FIFA now since year 7, year 8, they're in year 11? Just a verbal reminder, don't forget FIFA. Do some of them need FIFA still printed out on a sheet that you hand them? Do you need to give the FIFA mnemonic to the LSA and tell them if this particular student's struggling, please pass them this slip of paper as their reminder? Is it just going to be a quick question on the whiteboard? What's the mnemonic to help you do calculations? Get them to hold it up, check they remember it. You don't need to model this FIFA method this time. Another class, they can't all remember it. You're going to do a model with the FIFA one. So scaffolds are temporary. We don't want to remove the challenge from lessons, so this idea of deliberate difficulties. Don't give them that scaffold of FIFA if they don't need it at this point. So easy with calculations to provide within your worksheet increasing challenge. So the scaffold, such as mnemonic FIFA, can help students access the learning, but you can still have increasing challenge. Maybe you're going to use a similar equation that would give them the same outcome. Perhaps you're going to do more complicated conversions of units and more difficult rearranging. Add in that difficulty to keep your best students still motivated, even if the scaffold is there for others within that class. Visualizer, fantastic way to help students access the learning. So you can be doing calculations under the visualizer along with that verbal thinking out loud strategies that we've just talked about. Modelling to students is key with this, making the lesson accessible to all. So other ways we can do this is constructing answers together under the visualizer, showing students what great answers look like. Pick apart pre-prepared examples under the visualizer, talk to students, talk them through the process in reverse of creating a good answer. Midway through a lesson, you circulate in the class, you find an excellent example of work, get it under the visualizer, showcase students, this is what's required, this is what the outcome of this task looks like. So another mnemonic that's used to try and help students remember how to access questions, so a scaffold that is there for them as required, is CARS, so command words, annotate the question, reread the question, and then star. So you can show it on PowerPoint slides pre-prepared, or you can go through this thought process under the visualizer with students, provide them that example prior to expecting them to do a very similar question themselves. Or perhaps your adaptive teaching is going to be, well, I'm going to break the question down for them, but I know from my mini quiz with the whiteboards, I know they know the theory, I'm just providing the scaffold for them to access the exam question for the first time. Graphic knowledge organisers, again, another fantastic way to help students scaffold their thoughts and then enable them to write longer answer questions. So what do I know? What do I want to know? What have I learned? Would be one. The comparing what concept they already know with something they don't know. Let them organise their thinking. What are the similarities between? What are the differences? Then produce a summary of the new concept for them. So you're providing that scaffold for them to be able to access a question that might just be on an exam paper, 10 blank lines. That's scary, that's daunting, but actually you put this scaffold in place, enable them to access it, enable them to succeed. So here's an example I used with one of my classes about drugs trials. We watched a video. They had this scaffold in front of them, opportunities, threats. What are the opportunities for taking part in drugs trial? What would be some of the threats, some of the dangers? Then after watching the video, after getting their thoughts together in these two columns, they then wrote a conclusion. I told them how many lines I wanted. I told them how many points as a minimum I wanted them to include. We discussed what a conclusion meant. Slightly more challenging version available. Same idea, but you just choose a different scaffold for a different group where you were getting them to think in different directions. Another scaffold is to provide the keywords for students. So question 3 here, explaining the process of decay using the following keywords. You're giving them what you want them to use. You're still enabling them to access the outcome of the lesson, explain the process of decay, but you've put that scaffold in place to make sure every student can achieve. An A-level example here again, you want them to explain Heinz's work. You're going to provide them the tier 3 words so they can all access that learning. It's less daunting, it's less scary, it's achievable for all. Another example of it, you write in a paragraph, how to be brave, give students a connective, gives them the tier 3 words, set them up to succeed. That scaffold is there. Over time, this scaffold would be removed. You'd expect them to answer a similar question without needing the connectives, just the tier 3 words. Eventually, answer a question, longer answer question, without the connective, without the tier 2, 3 words as well. Fail and sailor attempts another way. So you get failed as their first attempt in learning. So students have to have a go. And then we respond to that. So perhaps in this example, you get them to write a point and explain the impact on the environment. You get students to collaborate, share their points, share their examples, tell them what the success criteria is for the task. Then give them some examples of answers. Deconstruct it. Can they see a point? Can they see an explanation? Can they see data? Get students to pick it out within answers. Show them different standards of answers. Point, explain, use data. Can the students recognise that one answer is better than the other? Can they justify, can they explain why answers are one better than another? And then give them their second attempt in learning at the same task. So they're describing the changes and uses of energy resources between 2 years. Give them the success criteria, the point, explain the user data. They can have another go. They've got their point and explanations now laid out. They've seen what a great answer looks like. Can they replicate themselves with that scaffold? Every student can now achieve that outcome because the scaffold is in place for them. You've modelled it to them. You've shown them what a great answer looks like. They now know what to do, how to do it. So in summary, adaptive teaching is about being responsive, but being responsive at each of these different stages. So in summary, for adaptive teaching to be successful, you need to know your children. You need to know what you're teaching. You have to have high expectations of them. And you need to be constantly asking yourself the question, how can you change how you teach to get all students to that same endpoint? But leave those desirable difficulties in place. Do not remove all that challenge, because that will stop students' motivation. If you have any further questions, then please get in touch.